Okay, so let's talk more about the hardware and software requirements for all this virtualization we've been doing. Um, as I've alluded to in the before, in the previous video, which if you haven't watched, you should watch it. It makes the most sense to watch these at least the first time in order. After that, if there's a point at which you're somewhat confused, go back and watch that video. But watching the whole thing backwards or randomly does not make a lot of sense. So, talking about our host computer requirements, a lot of that depends on the type of software that is installed and the kind of systems we're supporting, so systems we're virtualizing. Um, with Type 1 hypervisors, um, you have to really pay attention to the hypervisor requirements to make sure that the physical platform for that bare metal hypervisor is appropriate to what you're deploying. With Type 2, all you have to do is make sure that the version and the OS are compatible with the computer you're going to install them on. Now, the other side of that coin, which we may allude to later, but I want to make sure I bring out now. When you're choosing the hypervisor, if it hasn't been chosen for you, say, for example, you've got a new job in a data center and they're using Hyper-V for everything, or they're a VMware shop. At that point, you really don't have a choice. But if it is up to you, you need to look not only at um, the hardware requirements of the hypervisor that you're thinking about, the compatibility of the hypervisor you're thinking about. You need to think about the guest OSs and their compatibility with the hypervisor. If you know, for example, that a certain guest OS that you really, really need really doesn't work with a certain kind of Type 2 hypervisor, don't go that way. Don't don't paint yourself into a corner on the theory that, hey, I'll figure it out. If the entire industry has figured out that guest OS X and hypervisor Y do not play well together, don't assume that you're going to figure it out. Just go with the wisdom of the crowd, as it were, and proceed. So, in terms of let's see. So we've got a lot of things to think about here: processor requirements, hardware virtualization, data execution prevention. We'll get into that. So, processor requirements. You're almost certainly going to want a multi-core processor. Now, the good news here is that for workstation and server-grade platforms, you're going to have to work you're going to have to work pretty hard to find a processor that's not multi-core, that doesn't have multiple individual processor cores on the die. So that's probably going to be taken care of for you as long as you're doing a good job picking the physical hardware. But you do need to think about that. If you have a lot of VMs to run and you've only got one processor and it's only got one core, that's probably not a good idea, because that one processor is going to have to pretend to be 5 or 6, potentially. Not a good plan. Hyper-threading. Hyper-threading allows us to parallelize what would otherwise be serial operations. In essence, you create multiple virtual cores that the hypervisor can use to distribute amongst the computers, amongst the virtual machines. Also, another way of using the term hyperthreading is that as the CPU, as the OS is running the program that it's running, whether that's the hypervisor itself, if it's a Type 2, or an application, inside a VM, inside a hypervisor. It can look at what needs to happen and it can try to figure out, okay, how many of these things can I do at once? Which parts really have to wait on which? And it can figure it out and try to parallelize the processing. Now, we call this symmetric multiprocessing. It doesn't always work. Really and truly, there are a lot of things that we do in computing that really don't benefit all that much from aggressive parallelization. A lot of the things we do are just fundamentally serial in nature, and they just have to do them as fast as we can. Can't really parallelize them. hardware virtualization, which we talked about in the previous video, allows, actually, this is a different sense. The whole thing, in a sense, is hardware virtualization. This sense of hardware virtualization allows the processor to do some of that for itself to speed the whole thing up. So if the processor can pretend to be multiple processors, it'll do that. If the processor can pretend to be, I don't know, I/O, it'll do that. Then, of course, you've got data execution prevention. Data execution prevention is a pretty interesting concept as far as we're concerned with cybersecurity. One thing that, if you think back to what you might have heard about, say, buffer overflows or command injection or things like that, um, one thing that a malicious actor can do to try to get code running on a system where he doesn't actually have um, permissions to run code is to actually try to get an executable program inserted into data so that the CPU, not knowing that there's a program there now, will reach into that memory location, grab it, and pull it back and start dealing with what it thinks is data, but what is actually code. And that code will start running. So data execution prevention, both Intel and AMD have forms of this that we'll talk about later, allow the system to look at what portions of memory should belong to executable code and what portions of memory should belong to non-executable data. And if it pulls something out of non-executable, out of a data block, it'll know, hey, this is a data block. Whatever happens, I shouldn't run this as code. I should process this as data. Um, and this also helps the VMs isolate themselves from each other, so they don't step on each other's toes, share each other's memory, etc. In terms of your memory requirements, this is one of those things you're going to have to think about when you consider how many VMs you can deploy onto a given platform, and also how many of them you can run at the same time. This box here, I'd safe to say I've got about a dozen VMs. I haven't done the math to see how much memory all of them take up, but I can guarantee you that the total memory requirements of all those VMs significantly exceed the physical hardware I have available. So there's no way on earth I can run them all at the same time. That's one thing you have to think about. Um, if you know you have a whole bunch of VMs that you use just every once in a while, having significant overcommitment like that is okay. But fundamentally, figure out which VMs, what set of VMs you will likely have run at the same time, and make sure you don't push the limit there. You also need to have enough system memory for the host OS. For a Linux box, at least 2 gigs. For a Windows box, at least 4. For a server system, maybe at least 6 or 8. Let's see, the shadow page table helps the hypervisor keep track of the memory that it's got allocated. And actually, let me finish the rest of this in the next video. I've got a couple more slides to talk about, and I don't want to run out of time. Thank you.